So we're looking at a measuring aspect of heat. It's called as heat capacity, specific heat capacity, and molar specific heat capacity. The idea is the same. All the three talk about something called as heat sponge. Not an official term. It's a term that I'm using to talk over here. So please don't use that in your exam. So basically it talks about how much heat an object can take in for every degree Celsius. Now let me explain it this way. So we'll talk about first, I'll start off with an object. Say this is of mkg. And say this is at x degrees Celsius. I raise it to x plus 1 degree Celsius. How do I do that? By supplying with heat. I supply this with heat. And so it raises from x degrees Celsius to x plus 1 degree Celsius. So this amount of heat that I supplied, is your heat capacity of that object. So the term is kind of simple, right? Heat capacity. So remember, here you are raising from x to x plus 1. So that amount of heat is your heat capacity. Now, what is this specific heat capacity then? It's the same idea with a small difference. Heat capacity. It's the same idea with a small variation. The variation being it is for 1 kg. Okay guys, same object, same liquid. For example, same liquid. In this case, I'm using liquid, apparently. So here, if I take up 1 kg, in this case too, we are looking at x degrees Celsius to x plus 1 degree Celsius. This amount of heat is what is specific heat capacity. Because we are dealing with 1 kg. Now, instead of 1 kg, if I take 1 mole. So what is a mole? I hope you guys remember from chemistry. 1 mole is the amount of substance that can contain exactly 6.022 10 to the power of 23 particles. So if I have 1 mole and say this is at x degrees Celsius, I raise it to x plus 1 degree Celsius and I do so with heat. And this heat is your molar specific heat capacity. Okay, so that's your introduction. Let's look at the official definition and everything. So heat capacity is the amount of heat required to raise the temperature of an entire object by 1 degree Celsius. So obviously it depends on the mass and material of the object. Specific heat is the same thing, but instead of depending on mass, it does not depend on mass. It just depends on the material. So that is, specific heat is the amount of heat required to raise the temperature of 1 kg of an object. Again guys, it need not be a liquid itself. By chance, I didn't even realize that. I just took liquid. I could have just taken an object. But anyways, this is easy to show. While your molar heat is the amount of heat required to raise the temperature of 1 mole of an object by 1 degree Celsius. Again, it depends on the mass and the material. This too depends on the material. All the three depends on the material. The first one depends on the mass. Second one does not depend on the mass. Third one depends on the mole. So 1 mole has a particular mass, and so we have to go with that. So this depends on this is per mole, this is per kg, this is for the entire mass. That's why it is heat capacity. The heat capacity of the object. This is heat capacity of 1 kg of the object. This is heat capacity of 1 mole of the object of the given substance. And then what is the formula? Q is your heat supplied is equal to C times of delta T. This capital C is your heat capacity. Q can also be written as M times of C. This is small c delta T, where C is your specific heat capacity. So when you multiply specific heat capacity with the mass, you will get heat capacity. Molar heat capacity Cm can also give the heat supplied. Heat supplied is equal to N times of Cm times of delta T, where N is the number of moles. So first thing is, you might be confused between C and Cm and small c. Capital C is M times of C. Cm is capital M times of C. Small m is to do with mass of the sample. Capital M is to do with molar mass. And C is the specific heat capacity. So basically what we're telling is, if I know this, all I have to do is multiply this with M, which is the mass, and I'll get the heat capacity. If I know the specific heat capacity and if I know the molar mass, I can get the molar mass by multiplying with capital M. That's all. Does it make sense? Does this diagram help you? I mean, it has to. I mean, that's the point. Okay. So you can see the unit also reflects that. So heat capacity is joule per kg. So there's no mention of mass. Specific heat capacity is joule per kg Kelvin. And here molar heat capacity is per joule Kelvin. Sorry, not per joule, what am I telling? Joule per mole Kelvin. This is joule per kg Kelvin. This is joule per Kelvin. So here, even the SI unit reflects those two. So all in all, heat capacity is object based. Specific heat is per kg. Molar specific capacity is per mole. That's it. It's the same idea. It goes back to the same idea of heat sponge. It's just that the amount of material changes. Amount of substance that you have changes. It's the same material. How much you have, it changes. That's it. Okay. So yeah, I think you guys can start with this. And then this.